Hey everybody, for this project I worked on predicting the net electrical energy output of a combined cycle power plant. The data set includes over 9,500 hourly records, which features like temperature, pressure, humidity, and exhaust vacuum. And then our target variable is the energy output that we had here in megawatts. So to define the machine learning approach, we're going to use a supervised regression problem is how we're going to solve this thing. So we're going to use this as a regressional task. And our outcome is going to be how well we measure the PE, which will be the net hourly electrical energy output. And to evaluate our models, we're going to use the mean squared area, which penalizes the large deviations between the predictions and the actuals to kind of filter those out. So to explore the data, we started first by reviewing the summary statistics in the spreadsheet here. So I put all these numbers to round numbers, so round them up to so there's no decimal points, make it easier to manage. But so the temperature ranges anywhere from 1.8 Celsius to 37.1. The pressure would hover around roughly 1,000 mbar, and then the humidity varies widely from about 25% to 100%, and then the energy output ranged anywhere from 420 to 495 megawatts. So this tells us that the data set has good variability and coverage. Then for the feature selection and models, all 4 input features are physically relevant to energy production, so we'll include them. And for the modeling, I compared a linear regression for a simple baseline, and then we used a random forest regressor for handling all the nonlinear relationships, and we split the data into 80% training and 20% for testing with a 5-fold cross-validation on the training set. The linear regression model provided a baseline with an MSE that we can see here in our predicted output. The random forest reduced error significantly, showing it could better capture complex and nonlinear relationships between the inputs and the energy output. And this makes sense because the turbine performance is not purely linear with respect to the environmental variables. So if we come in here and we look at how that plotted, we'll see on the blue line the actual energy output and then the predicted energy output there in red. So it was pretty accurate there as it followed that at the model to do that. So in summary, the project demonstrates how we can use machine learning to optimize power plant performance predictions, and then accurate forecasts can directly impact operational efficiency, scheduling, and cost savings. Thanks for listening.